We love to write code. As for me, even after quite a few years of being a professional programmer, I still get the chills when I get to the office in the morning. I sit down in front of an editor and I start implementing of what is planned for that day. With a cup of tea, with headphones on my ears, it just feels great. And there are many moments like this in a programmer's life. But sometimes there are moments that are a bit less perfect. When our code matures, when it becomes complex, sometimes it becomes less friendly to work with. And that fills us with frustration. Luckily, people have come up with methodologies, with paradigms that aim at keeping our code from going astray, that aim at keeping our code clean and maintainable at all times. We Ruby programmers tend to prefer object-oriented programming to other paradigms. And OOP consists of principles, of rules, of design patterns, and best practices that help us out in everyday programming. And there are many rules in OOP that we discuss widely in our community, but it is hard to follow all of them. As good as it is, it sometimes may feel even impossible. Sometimes the principles are even contradictory. So today, I have chosen 3 principles that I find most important in my programming life. The first principle is single responsibility. As formulated by Robert Martin, single responsibility means that a class should have only one reason to change. That is nicely said. But when we sit in front of an editor and we implement the class, how do we know that the class have only one reason to change? That is not always easy. Let's have a look at some examples that show us how we can do this. Let's say we implement a service for our local internet provider. We have some users and we want to calculate the bandwidth usage for the user for certain months. A natural thing to do is to implement a bandwidth usage class on that user. But this is how we end up at building these God classes, that users that span many lines of code. How many of you have seen a user class that had more than 500 lines? Yeah, quite a few hands up. So how do we get around this? We should understand that just because of the fact that bandwidth usage calculation includes a user, we do not need to implement this on a user class. This is a separate responsibility, so we can abstract it to the separate class so that we can get our code cleaner and we can reuse the code in future. This is a simple example because we kind of understand the different responsibilities by merely relating to our intuition. It is not always that easy. Sometimes we just need to spot some repeating patterns in the code that indicate that we might be introducing multiple responsibilities. And one of such indicators is a private method. I'm not saying that every time we implement the private method we introduce multiple responsibilities, but oftentimes it happens that we do. Let's have a look at another example. Here we have a shipment class, and we want to update some attributes of the shipment class. We deliver via arguments a full name, and we extract a first name and a last name because that's what the shipment class needs to do in this situation. We see some repetition, so extract it to a private method. That feels great. We don't do repetition anymore in the code. We hide this from external interface, but when we look closer at this private method, we figure out that it has nothing to do with the shipment class. It deals with strings, it deals with extraction of names, which can be quite complex logic. It is easy for Polish or English names, but if you think about these Brazilian names, for example, it may be very difficult to get all these pieces of the names into separate variables. So when we think about it, and we see that this is completely separate responsibility, we extract it to another class. We could create a name parser class that deals only with this responsibility. What do we get by this? In every place in our application, we can use this logic by using this class. But a side effect of this is that we can unit test this class in isolation, and we can reuse it also outside of the application if we package it correctly. In the shipment class, we just use the name parser, And as simple as that. We could go further with the refactoring, we could inject the dependency, but for now I'll stop here. The thing with Rails is that Rails do not always let us follow the SRP principle. And the main reason for that is actually active record. Active record is an object that wraps database access and adds behavior. It carries both data and behavior. By definition, active record violates SRP. And for now in Ruby, we do not have, whenever we do active record project or we do data mapper project, version 1, we always are stuck with active record. There is this other pattern that is called data mapper, but for now we don't have the implementation in Ruby, although guys at data mapper project do their best to deliver it. I think they are like halfway through right now. So for now we are with active record, and developers have found that in some complex applications, this may become cumbersome. So developers have come up with some solutions to mitigate the problems. So one of the solutions, quite popular, is to extract behavior from active record objects, to stick them into modules, and to include that modules into the active record objects. This tends to work quite well in practice, but this does not solve the problem. We only move the code around in the file system, but the responsibilities are still there. The modules are still hard to reuse. Another solution, quite often discussed recently, is to introduce this separate layer of domain objects. Domain objects or business objects. In this scenario, the models in Rails merely wrap the database access, they are just data access objects, and the domain layer objects wrap them and add behavior on top of them. And the third solution, quite often discussed recently, is something that Avdi Grimm proposes in his Objects on Rails book. And so what Avdi does, he explicitly hides the external API of active record objects behind, he hides this from external access. So everything that is implemented on active record can only be accessed within the object, and we should explicitly write the external API for that object. But there is also another reason for why we often violate the SRP principle. And this is more human-related. Michael Feathers, in one of his presentations, asked this simple question. Is it easier to add a method to an existing class, or is it easier to add a method to a new class? The sad truth about this is that it is usually easier to add method to existing class. There are a few reasons for that, but I think the most important one is that if we want to create a new class, we have to come up with a name for it. And we all know that naming things is not the easiest part of computer science. While we are at naming things, we move to the second principle that I follow quite strictly in my everyday programming, and this is domain language capture. Let's think about writers for a second. What makes Dostoevsky great? I think there are two features that makes writers great. The first one is that they are able to understand the world around them very, very well. But there is also a second feature, and this is that they are able to express their understanding in a way that the readers understand it. Think about it when you read a good book. Oftentimes, after reading the book, you see the world differently. But oftentimes, you think that, how come it never happened to me? That how come I didn't understand the world in this way before? And this is because they understand, because they name things correctly and they express it correctly. And this, I think, should also be applied to coders. We, as coders, should have the understanding of the business model we model, of the business logic we model, but we should also be able to express it correctly in the code. It's so tempting to name a class a manager or a helper. I feel an urge to do so quite often. We can always change the name later, don't we? But every time I hear this question, we can always change the name, I stop and think, And usually this indicates that I do not understand the reason for the class. So this is a great moment to stop, to think, to understand, and give a proper name. It is actually quite known fact that naming things properly, naming models properly, is at the center of object-oriented programming. But what I think is that we should not restrict ourselves to models. We should span all the layers with good naming. We should go to controllers, we should go to helpers, we should go to views, we should go to HTML, to CSS, to JavaScript, or CoffeeScript if you prefer. But very important thing also is that we should span this to communication with our client. And no matter if it is client who pays you for the job, or maybe it is you creating your own product, there is always a gap between the language that client uses and the developer uses. And we should close the gap. Usually we think that it's the client who is responsible to use the domain language. I think it is not always true. I think we developers should also try to make clients to use the proper language. And we should also try to help them to understand the product they're building. Let's have a look at a simple example when things can go wrong. Let's say a client asks you to build a simple blogging service, surprisingly. They want to have the ability to post, they want to have the ability to tag the post, so you build this simple thing. You probably have a tag class in your code, everything seems fine. Some time passes and out of nowhere the client starts calling the feature not tags but labels. In logic nothing happened, it's just that the name of the feature changed. So you do not update your code, because why would you? Everything works fine. You just update the copy in the browser. But more time passes, and what happens is that the client comes out with a new feature, which is called tagging, and you can tag users in your posts. Pretty awesome. You introduce a new class, you introduce user tag maybe because tag is already taken, and everything might look nice. But then when somebody new comes to your code, or maybe just your future self, you look at the code and you arrive at something like this. You have a tagging feature which you can see clearly in the browser, and you have a tag class in your code. But these two things are completely unrelated. They are completely different features. This breeds a lot of confusion. And this breeds a misunderstanding. So my advice is, whenever you work with clients or you work with your code, you work with your co-developers, always unify the naming. Never underestimate the importance of naming things in your code. Because when you have naming right, you always stay in sync and you can always communicate clearly and everybody always know what you are talking about. And staying in sync is actually at the core of the third rule that I find most important in everyday programming, and this is dry. Do not repeat yourself. Do not repeat yourself. Do not repeat yourself. Dry is at the center of race. While doing race, we often stay dry without even noticing it. If you think about how model attributes are derived from database schema, if you think about how view partials are implemented, if you think about how we define routes, we just stay dry by following the simple guidelines of building race applications. However, does it mean that we can't violate the principle? Of course it doesn't. It happens quite often. It is more common to novice programmers than to experienced ones, but it happens all the time actually. And the simple way of violating this principle is by duplicating the code. This, however, is quite simple to spot and quite simple to refactor. The important thing to understand about dry is that it is not only about code. It is about knowledge. And firstly, we can duplicate knowledge within our system without really duplicating code. And secondly, we can duplicate knowledge outside of the production code. And a classic example for the latter thing is comments. So when you comment on what the code really does, this is duplication of knowledge. Let's look at this example. We concatenate two strings, we have good names, So we can read Ruby, we know what the line does, we do not need the additional comment about it. We just understand it by merely understanding the Ruby language. And this is for us coders, and if we have the name good, even our clients will understand what does it mean. What happens if we do this like this? Time passes, we update the line, and we need to remember to update the comment because there will be no warning whatsoever to remind us about it. This is how we get out of sync, and this is how we get confused. A second example will be a bit more complicated and will be about duplicating knowledge without duplicating code. So let's say we have a user class again, and we can grant admin privileges to the user class by setting a Boolean flag. How do we do grant privileges? We set the Boolean flag. Let's say we have a couple of places, a couple of processes in our application that we need to grant privileges in. So we just repeat this line. It's not really code duplication because it's single line after all. But when the process of granting user privileges changes, we need to update every single place in the code to embrace this new knowledge. Oftentimes we just forget about one place or another, and this is how we introduce bugs. What is the solution for that? Again, name the business process. Give a proper name to the business process, and when you have the name, encapsulate it. We could either encapsulate it in a method on a user class, or we could even go further and encapsulate it within a separate class that's single responsibility is to deal with granting admin privileges to the user. So we have the three: single responsibility principle, domain language capture, and do not repeat yourself. Following the three principles makes our code better. Following the three principles actually makes our code stay good. And if our code stays good, we can keep the good mood from the morning when we sit in front of an editor with a cup of tea, with headphones on our ears, throughout the whole day. We can keep the enthusiasm from the beginning of the project, throughout the whole lifespan of the project. And last but not least, just thinking about the principles make us become more aware of the decisions we make. And by becoming more aware, we simply become better programmers. So let's get started today. Any questions?
When you say that we should talk on the same language as customer talk, but for customer it's quite hard to explain single responsibility principle, and the customer would never know about that. For customer, every object has many responsibilities. And don't you think, how do you think, how can we solve this conflict between single responsibility and talking on the same language as a customer do?
I think customer does not need to know about single responsibility. They explain the problem, then they explain the processes that they want to have, and single responsibility is for customer is somehow an implementation detail that we have in our language. It's just that the language that we communicate is the processes. We need to have the names in common. So when a client says that they want to be able to calculate bandwidth usage for a user, a natural thing to do for us is, okay, that will be a method. So what I am saying, this should not be a natural way of solving this. We should still have the name like calculate bandwidth, but this not necessarily has to be a method. This can be a class that encapsulates that process. Does it answer the question? Any more questions?
Great talk. Just one question. You gave an example of a class, and the name of the class was not a noun, it was a verb. Yes, exactly, this one. Can you comment on that?
Sure. We are accustomed to giving names to classes as nouns, but if you follow this discussion recently in the community. For example, Corey Hines encourages us to give the names of the class as verbs, and it may seem quite cumbersome at the very beginning, but actually when you get accustomed to that, I find it pretty good to understand what is the process about, what does the class really represent, because sometimes the class doesn't represent an object, it represents a process. So it also is kind of an object, but it's more related to what the class does in general. And in this example, we could name the class like admin privileges granter, but for me, this just reads better. For me, when I see this in the code, it feels better to me. Service. It's kind of a service class, yes. More questions?
Any more questions?
There is one. Michał? Bart.
Bart.
Hey, thanks for this great talk. I got a question regarding active record that, yeah, single responsibility problem that you just spoke of. How are you doing it at the moment? There are some trends where you say you would create a kind of a repository object which is solely responsible for storing objects, and everything else goes into like DCI approach or like domain objects models. But yeah, right now this feels a little bit like the modern approach to me, and this may change already, or I don't get my head around it when I try to apply it. What kind of strategy do you prefer at the moment?
In most applications that we currently build at Applicake, we introduce this another layer of objects. So we wrap the models with additional layer that introduces behavior, but we are not very strict about it. So if we think that from the controller it actually makes sense to access the model directly, we do so. But when the logic is a bit more complex and it involves maybe more than one model or just more complex behavior, we try to introduce this another layer that wraps the behavior, that wraps the model object and adds additional behavior on top of it. No more questions? Maybe one more?
Yeah, that's it. Thank you.
Thank you very much.